We were looking at the bowel work on our lesson 8 guided notes. We went from lesson 6 to lesson 8. We skipped lesson 7. There is no lesson 7. So for our bowel work, how is the process of multiplying fractions different from adding and subtracting fractions? Yeah, for what is important about adding and subtracting fractions? What do you need? What has to be the same in both the fractions? Yeah, so for adding and subtracting, you must have a common denominator. Do you need a common denominator for multiplying?
No.
No.
You don't need it
For multiplying, no. When you multiply your numerators, you multiply your denominators, and then you simplify. For multiplying and for dividing fractions, you do not need common denominators. If you are adding and subtracting, you must have a common denominator before you add or subtract. Today's lesson, the heading for our lesson is dividing fractions. It is the last lesson of this unit, and our target is I can divide positive and negative fractions. So if we move on to the notes, when you divide fractions, you multiply by its multiplicative inverse or reciprocal. Okay, so does anyone remember what the reciprocal is?
Nope.
It's known as flipping or switching your numerator and denominator. So your reciprocal is when you flip your numerator and your denominator. If we had 2/3, what would the reciprocal of 2/3 be?
Oh.
3 seconds or 3/2, 3/2. You flip the top and the bottom, or your numerator and your denominator. When numbers are written in a fraction, what operation are we doing? This fraction bar means what operation? Division. When dividing with mixed numbers, change the mixed number to an improper fraction. And any whole number can be changed to a fraction by what? If we had 7, how do we write 7 as a fraction? Yeah, by writing it over 1. Okay, so if we move on to our first example, we have 1/3 divided by 5. What 3 letters do we use for dividing fractions? KCF. Our K means keep. Okay, so keep, change, flip. Before I do anything, how do I write 5 as a fraction? Over 1. And then I want to KCF. Keep, change, flip. I keep 1/3 the same. So I'm going to bring that down, or if you want, you can write it over to the right. I change my division sign to multiplication. And I flip my second fraction. What do I get if I flip 5 over 1? 1 over 5. And now we have multiplying fractions, which is what we did yesterday. to multiply our numerators. 1 times 1 is 1, and 3 times 5 is 15. Can 1/15 be simplified? No, that is our final answer. Okay, for our next problem, we have 3/4 divided by -1/2. So we're going to use what 3 letters? KCF, keep, change, flip. I keep 3/4 the same. I change this division sign to multiplication, and I flip my second fraction. What does it become? 2 over -1. And I multiply my numerators. 3 times 2 is 6. 4 times -1 is -4. So I know I have a negative number, but this can be simplified. How many times can 4 go into 6? 1. And how many are left over? 2, which becomes our new numerator, over 4. Can we simplify this further?
Yes.
By dividing by 2, so we get -1 and 1/2. Remember your rules for multiplying and dividing fractions. If you have the same sign, your answer is positive. Different signs, your answer is negative. Okay, let's try our next example. We have 2/3 divided by 3 1/3. Anytime we see a mixed number, what do we want to do? Change it to an improper fraction. So 3 1/3, we'd have to multiply our denominator times our whole number. 3 times 3 is 9, plus our numerator is, so we have 10/3. So we have 2/3 divided by 10/3, and we need to do what 3 letters? KCF. We keep the first one the same, so 2/3 stays as 2/3. We change this division sign to multiplication, and we flip our second fraction, so we get 3/10. Before you multiply, what do you notice about a number in the numerator and number in the denominator? Yeah, they're the same. You can cross cancel. What's 3 divided by 3? 1. So now we can multiply. 2 times 1 gives us 2. 1 times 10 gives us 10. Can we simplify 2/10? By dividing by 2. 2 divided by 2 gives us 1. 10 divided by 2 gives us 5. So our answer is 1/5. Okay, for our last question, the side pieces of a butterfly house are 8 1/4 inches long. How many side pieces can be cut from a board measuring 49.5 inches long? So we're taking 49 1/2, and what operation are we doing? Division. We're dividing by 8 1/4. We have mixed numbers. Do we like to work with mixed numbers when we're dividing? No, we want to change them to improper fractions. What is 49 times 2? 98 plus 1 is 99. So we have 99 halves. And 8 1/4 number. 4 times 8 is 32, plus 1 is 33. So we have 33/4. I'm going to rewrite this problem. 99 halves divided by 33/4. And we're doing what 3 letters? K, C, F. Keep, change, flip. So I keep 99 halves. I change my division sign to multiplication. And I flip my second fraction. So I get 4 over 33. We don't have any of the same number, but is there any cross canceling we can do? So 2 and 4. What is 4 divided by 2? 2, so that we write as 2 over 1. And what about 99 and 33? What's 99 divided by 33? You can divide these two. 99 divided by 33 is 3, so we get 3 over 1. We then multiply our numerators. 3 times 2 is 6. 1 times 1 is 1. 6 over 1 simplifies to 6. So there's our answer. Go ahead and try the on your own.